Hello everyone, my name is Saili Kadam. In this video, we will be talking about underfitting and overfitting. So if you would have observed in our previous videos, there were some times where we discussed underfitting and overfitting, where I said that we will be discussing these concepts in detail in our upcoming videos. So in this video, we will be going through the concept of underfitting and overfitting. So let us get started. So basically, why do we train our models? Why do we want that, this model predicts this or this model classifies into some groups? So basically the main goal of machine learning model is to perform well or to get accuracy when it comes to unseen data. So we want our model to perform well on the testing set, I would say, or when we use our model in our real life or day-to-day uses, it should be able to predict things accurately. This is why we train our models. So let us take an example and understand a thing. Let us say I have a student who has a exam, let us say. So basically when we say that we are testing something, so what exactly we are doing, we are taking exam of our model. So let us say there is one student one, so he don't study at all. Let us say it's simply addition and subtraction test. So a teacher has given 10 examples has solved 10 examples in the classroom. This student only goes through 2 examples. So, do you think how will the student perform in practice test or in actual exam? Obviously, even in when it comes to practice test, this student won't perform well because he had just solved 2 examples, which are not enough to understand the concept of addition and subtraction. And then eventually in the final exam as well, the student won't score well. So is this a ideal condition? No. Let us say we have another student, let us name him S2. So S2 goes through all the 10 examples solved in class, goes through each and everything. But the issue is that he memorizes everything. Or let us say 10 examples were given, he learned all those 10 examples. So what happens is in practice test, let us say the teacher gives 8 examples that were already solved in the class. So this student performs very well when it was simply a practice and test. But when it was final exam, when new problems were given to the student was not able to perform. So is this ideal condition? Both of them are not ideal conditions. So what exactly is expected from a student? It is that student should understand the core concept. If student understands how addition works or how subtraction works, he don't memorize anything. He only understands the core concept of the addition and subtraction. Then no matter which example is given to the student will able to solve it. And that is the ideal condition. This is the reason why we are taught in the class. Why are we taken examples of addition? So that we understand how addition works. And once you understand how things internally work, automatically you will understand the concept, and even in the practice exam and also in final exam you will perform well. And this is what we want from our model. So there are two conditions. Either let us say our training data is too small, we just have 10 examples to train, then the model won't be able to understand the patterns, it won't understand anything, and there is a very high chance, so model becomes very simple because the training set is very small. So the model won't perform well, it will obviously not perform well. Then different condition, let us say I have 100 or 200 examples in training set, so the model performs so well when it is given that test case. But when we have completely different set, the model may not be able to predict because it simply memorizes the training set. and we don't want any of these conditions. We want our model to understand the patterns, understand how exactly things work out, or how exactly the pattern is. Let us say if we are building up a model to predict whether the mail is spam or not. So we don't want that model to go through each and every mail and memorize it. We want it to understand, like, if this keywords occur in this mail, then there is a chance that this mail is spam. If this don't work, a word don't come in this sentence or don't come in this mail, then the mail is not spam. So the main aim is accuracy. The model should give us accuracy on unseen data. So that is why we train our model. And these two conditions that we discussed, that model either don't learn at all, and model learns too much that it also starts picking up the noise. So both of them are not ideal conditions, and these are basically overfitting and underfitting. So let us discuss in detail what is underfitting. So as I said, the let us say we have very limited training data, very limited training data. Let us say we just trained our model on 5 or 10 examples. So do you think the model will able to capture the patterns or the behaviors? Obviously not. So it will perform poor on both the training side and unseen. So it won't give us accuracy at all. It won't even be able to recognize the seen patterns, and on unseen patterns it will obviously not be able to perform well. So it is underfitting when our model becomes so simple or the training data is so limited that model is not able to pick up any patterns from it. So it don't perform well on both training data as well as testing data, which ultimately results in poor accuracy. This is underfitting. And there is one more thing, overfitting. So overfitting is simply the machine learning model memorizes everything. It starts memorizing the entire training data, that it starts picking the noise, the unwanted, the outliers, everything. It starts picking everything, and ultimately, so it basically memorizes entire training set as it is. It learns from the noise, it learns from outliers, it starts learning from everything. So what happens is it performs too well on the training data, because as we discussed, a student, it memorizes all the examples that were covered in the class. So what happens is in practice test, the student performs so well. So when it comes to the training data, the model performs too good. But when unseen data is given to the model don't perform at all. So it gives poor performance on unseen data. In underfitting, it don't perform on training data and even on the testing data. Whereas in overfitting, it performs fantastic, performs amazing on training data, but on unseen data, it don't perform well. This is basic concept of underfitting and overfitting. Then the important difference in between underfitting and overfitting is that in underfitting, model learns very very limited knowledge it takes. So just remember the example that we discussed of the student. 10 examples were given, or 10 examples were solved by teacher in the class. In underfitting condition, the student, what he or she does is he only solves 2 examples. So he don't understand the concept, he don't even go through each and every example covered in the class. So the student learns very little. That is underfitting. When it comes to overfitting, what is overfitting? Overfitting is the student goes through 10 times, the student goes through those 10 examples, such that the student end up memorizing each and every example. This is overfitting. When it comes to underfitting, the model is so simple. It is like it don't know anything, it can't even predict the outliers, it can't predict what are the patterns, it can't perform anything. So model is very simple when it comes to underfitting. And overfitting is model becomes so complex that it start picking up the noise also. So that model is very complex. Then in underfitting we have poor training and testing accuracy. Both the accuracies are very much poor. Whereas in overfitting, it 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 gives you high accuracy when it comes to the training set, but when it comes to testing, it gives us very low accuracy. And then there is a very important concept of bias and variance. So both of them are errors. Bias is also an error and variance is also an error. So we will discuss it now. So in case of underfitting, we have very high biases. So when model is very simple, we call it as biases, or the error is called as biases. And variance is when model is very complex. At that time, we have high variance. So these two are again very important concepts. So let us discuss them in detail now. So bias is basically when we have our model. So as the same example, let us continue with the same example. We have students who don't learn anything. So in case of underfitting, so biases is basically an error that occurs. Bias and variance, we have two concepts, underfitting and overfitting. So to measure how much, so when there are two possible conditions, that either the model is so simple or the model is too complex. So both of them, to measure both of them, we use the concept of biases and variance. So biases is a error when model is too simple that it is not even able to capture the patterns. So bias is an error. So both of them are errors. Remember this. But bias is an error that occurs when the model is too simple that it is not even able to capture any relationships in between the data. So that is basically biases. And the opposite is variance. Variance is the error when the model is so complex that it starts learning from noise as well. So if we want to measure, we have two possible conditions, that either the model is very much complex that it is not able to capture anything. To measure that, like how much simple the model is, we use the concept of biases. And variance is the model is too complex. To measure again that, we have a different concept or different error. So let us say we have this as actual point. So if the model is so simple, let us say it is so it wants to predict this, but it predicted this because of model is very much simple. So basically this is error, that this is bias, how much bias it is. Or let us say the model is so complex, it turns, this is not the exact accurate definition. Just to understand, I'm just simply taking this example that this is variance, like how much it gets fluctuated, or from actual point, how exactly when the model is very simple, what are the fluctuations in the result, and when model is too complex, what are the changes in the data or changes in the result. This is basically bias and variance. So if we are asked to define what is bias and what is variance, so bias is an error that occurs when the model is very much simple, too simple model, and biases occurs in case of underfitting. And the next concept is variance. So variance is the error that occurs when the model is so complex, and variance occurs when there is overfitting in the data. So these are very much important concepts of machine learning, that is overfitting and underfitting. When we are learning any model, these concepts are very important, ki what is exactly overfitting and what is underfitting. So we should go through this, and then when we have overfitting and underfitting, we will ultimately have bias and variance, because they are the measure of these errors. So we should go through this. So this was all about underfitting and overfitting. In our upcoming videos, we will be again discussing further algorithms that we are discussing, and then we will also discuss some of the important machine learning concepts that we need. Like today we discussed underfitting, overfitting, and bias and variance. So we will continue in our upcoming sessions. So that's all for this video. Thank you.